Hi everybody and welcome again to your channel Thermal Engineering Concept and a Principle. In this video I about geothermal heat pumps technology, where can be used, when can be used, what are the advantages of using them. This is just a part from uh, two videos about the use of geothermal energy. And in that uh, sense of uh, information to be given, I will pass as a step by step for these applications which can be used in modern life technology. Now, let us pass through the objectives of the present video. Uh, the first thing we should know the geothermal temperature profile and how the temperature varies with depth. Secondly, the advantages and disadvantages of the utilization of geothermal energy and the geothermal heat pump technology and the main components of this machine. And we will go through um, types of geothermal heat pipes. In fact, here the types are related to the uh, type of ground heat exchanger, which is either borehole, vertical, or horizontal heat exchanger. And finally, as usual, we will pass through the closure and as a summary for the video and the content of the episode. Now let us consider the geothermal energy and the temperature variation as we go deep in the ground. We may find this table in the open literature, which shows the variation of temperature with depth. For example, for depth between 10 meters up to 200 meters, then the temperature will be around 30 Celsius. If we go deep to 2.5 kilometer, then the temperature may range between 30 and 90 Celsius. And if we go more deeper in the ground, up to 5 kilometers, then the temperature will be more than 150 Celsius. Of course, this range of temperatures and depth gives a sort of guide to know about the temperature variation of Earth with depth. But again, it depends on the climate and the geological structure of Earth. There is a term called geothermal gradient, which refers to the average rate of temperature variation with depth. For example, in Europe, the geothermal gradient approaches 30 Celsius for each 1,000 meters. Of course, this is again a general guide. It depends on the earth where we are dealing with. For example, in Iraq, uh, some of the studies show that the temperature variation is around 21 Celsius per 1,000 meter, and maybe in other places you will find another value. So it depends on the climate and where we are treating these values for geological effect. Now, let us talk about geothermal energy, for example, advantages. And there are many, maybe, factors can be explained and mentioned here, but I will focus on some of them. We have uh, Earth provides energy which is environmentally friendly source. It is renewable energy and stable at the same time. Uh, as well, it is profitable for heating and cooling, and we may save money for that, maybe arrive to 60, and sometimes it depend on the manufacturer, may arrive at 65%. And we have small land footprint because these systems doesn't um, people, I mean, for the heat pump, it doesn't need a large area to be uh, installed. And at the same time, there is no need for fuel to operate these systems. So they are clean, and the pollution is limited. And disadvantages of this system maybe depend on the scale of where we are using these systems. For example, if we are dealing with a geothermal power plant, large one, that may cause, and here may cause earth fractures and earthquake. And we have investment. If we talk about the cost of electricity, when you compare this energy source with other renewable energy sources as well, is high. And the initial cost, especially for heating and cooling system, here we are talking about heat pumps, is a quite expensive, but you can get this money back with the time, and then you will get a cheap uh, heating or cooling um, for your home, and the feedback could be within a few years if we talk about that, and it provides around 65%. And these heat pumps are efficient more than heating, ventilation, air systems, other types. Therefore, uh, although it cost a lot at, as an initial cost, but with the time, the payback is good for the uh, home holder. And we have uh, heat pumps usually need an auxiliary power source. Therefore, it needs another source to operate. And maybe these are the most important points to be mentioned for these advantages and disadvantages of heat geothermal energy. And now let us describe how the heat pump machine works. This illustration shows uh, the main components in this machine are evaporator, compressor, condenser, and expansion valve. So the cycle starts from the operation of the evaporator. Then we have a geothermal source, which already extracts energy from the ground, passes through a heat exchanger, which is called evaporator, because it evaporates the circulated fluid inside the heat pump. Then this source, it could be any fluid that circulates in the heat exchanger, return to the ground heat exchanger to heat up and return back to compose a closed cycle. Then, if we go back to the fluid that is circulated in the heat pump, it is evaporated, passing through compressor where it is compressed to higher temperature and pressure. Then it passes through another heat exchanger, which exchanges heat with other service fluid. So the fluid which is circulated in the heat pump is condensed, and during that process it just reject energy. The fluid on the other side, which comes from the utility, which is called the fluid, extracts energy, heated up, which follows the red arrow. Then it will leave the unit or the heat pump as hot fluid, goes to the utility, serves the other equipment, and then return back to this heat exchanger. So the fluid, which is already condensed in the heat pump or in the heat exchanger, in the condenser, passes through an expansion valve to expand the fluid, reduces the pressure, and then return back to the evaporator to compose a closed thermal cycle as well. So this is how the operation is composed and how the energy is extracted from geothermal source to be utilized in heating process in this example. In this system, we have the heating mode where Earth works as an energy source to the fluid which passes through the borehole in the blue direction, which extracts energy from the ground and then return back to a heat exchanger, which is a part of the heating pump. Then this fluid will give energy to another circulated fluid, which we have explained in the previous slide, and then that will provide energy to space. In that way, we have extracted energy from Earth and transferred to the, for example, domestic use in this example, then heat can be transferred from ground to the utility. In this case, we have the utility as heating for um, house or maybe in a restaurant or other applications. So this is the heating mode, how the heating mode operates. And now let us have a look at the cooling mode of this type of heat pumps. Here we can see that the hot fluid return back from the heat exchanger and passes through the borehole in the red side which reject energy to the ground to cool down and return through the blue line to the heat exchanger. And this heat exchanger is a part of the heat pump itself. In that system, a hot stream is coming from, for example, the space, passing through this heat exchanger, cooled down, and then the cooled down stream returns back to the space for cooling purposes. So in this system, we are transferring the energy from the space through the heat pump to the ground. Here, the ground works as a heat sink rather than a source of energy for the heating mode, as we have explained in the previous slide. And now let us move to the horizontal ground heat exchanger. And the system is similar to the previous one, except that the ground part is composed of the ground and a horizontal heat exchanger. And the heat exchanger is usually made of plastic material such as high density polyethylene material. Uh, these plastic materials, they have the capability to resist temperature, corrosion, and they can handle high pressure as well. Although we are talking about low pressure range in the for the fluid that is passing through these pipes, but again, they can handle high pressure. And usually the pressure may be within between 2 and 3 bars for the fluid, which is usually liquid, is pumped through these heat exchangers. And the heat exchanger is made of um, uh, a configuration for slinky pipe. One slinky pipe could be buried in the ground, and the heat exchanger composes of multi-slinky pipes, and these heat exchangers have been already described in previous episodes uh, of this channel. So the fluid follows the blue line, which is cold, passing through the heat exchanger, heating up to follow the red line, enters the heat exchanger, which is a part of the heat pump, heating up the circulated fluid in the heat pump, and then that will transfer energy to the space. And the space could be domestic application or restaurant, public establishment, and many other applications. Even you may take a hot water to use in utilities in industry. So the operation of this system is closed system that transfers energy from the ground to the space with the help of a heating the heat pump and uh, maybe these applications they are now more than millions uh, installed in different countries for making the advantage of the ground source geothermal renewable source. Similarly to the system where we have used the heating and cooling mode in the borehole, We have here the cooling mode, and here, repeatedly, the ground works as a heat sink, and energy is extracted from the space, transferred by this system of heat pump, and then it is rejected to the ground. And then in that system, we have a closed system where the fluid passes from the heat exchanger, which is a part of the heat pump, down to the ground. Of course, we are talking about efficiencies. These systems are efficient, and they are useful and profitable to be used in heating and cooling modes, although it depends again the depth which we are talking about and the temperature. It depends on the climate and the place, I mean on geothermal structure. Although we have the temperature usually is range between 7 to 24 Celsius in the underground. Uh, and can be used for heating and cooling in winter and summer seasons. And now we have arrived at the point where we should mention a closure for this video. Um, we described geothermal energy and the range where the temperature profile and where can be used. In fact, in heat pump technology, we talked about heat pumps and how do they work, as we have seen in the animated illustration for the purpose of extracting energy from the ground and passing it through heat exchanger to be used and transfer the energy to a working fluid which can transfer uh, heat to a utility. And we mentioned the types of geothermal heat pumps. Of course, these types are classified according to the type of ground heat exchanger used in these machines, such as horizontal slinky pipe or a vertical borehole. And finally, useful sources you may find in the internet. Not only these sources, maybe you can find others. I mean, where the advantage of these literature can be of a great help to you to get some idea about heat transfer and not to forget that we have previously mentioned and published at least two videos about geothermal energy. I prefer if you go back and see them as well to understand the reality of using this renewable energy and the advantage of uh, so um, thank you for watching, and please subscribe to allow us release more videos. And I am waiting for your feedback, if possible, to see if we can add more topics to this channel. And thank you and have a nice time. Bye bye.